Hi, it's Dr. Myers again, and this is part two of the theory of the firm. And the last screen, we came after some discussion to two different things. One is that the marginal revenue product of labor equaling the marginal expenditure on labor, typically the wage rate, is the profit maximizing hiring decision. It is a point of optimality. It is, a desire of ours to make sure that we hire in a profit maximizing way. But we also, in the very last screen, proved that that's equivalent to the profit maximizing output decision that we make in the product market, that we look at all our marginal cost, we look at the marginal revenue coming in, and we decide to produce when marginal revenue equals marginal cost, and that's a profit maximizing output decision. So it comforts us that it is the same whether we try to maximize our profitability by our hiring decision, that is our factor input decisions, or if we try to profit maximizing uh, on our output decisions, we do the same thing. So the original table that I showed you in part one, we're going to see something like it very soon, equates labor and output through the production function, and it turns out, much to our pleasure, that that relationship works on both sides, the factor market and the product market, to achieve our uh, optimum goal of profit maximization. Now, just I think I've just because I had this thought, I've got to say, profit maximization means the greatest profit your firm under the current conditions can achieve. Well, profit can be negative, so it could be a loss. The only advantage, or the only thing you can take from that with a lot of satisfaction is that if you've done everything correctly in your firm to get to a profit maximizing level and you are making a loss, it's a smaller loss than any other position you could be in. So a note on on the marginal um, expenditure of labor before we go on. Just as marginal revenue is a function of the elasticity of demand, meaning that in every case except perfect competition, in every case except where the elasticity of demand is perfectly elastic, marginal revenue will actually be less than the actual price. So if you're thinking I'm selling this at a price and that's my marginal benefit, every time I sell it, I get an extra one. Not if you're facing a downward sloping demand curve. Your marginal revenue, your true marginal revenue is actually a little bit less than the price that comes in. Well, MEL is exactly the same thing. And it turns out that if a firm has monopsony-like power, monopsony, that is a single buyer of something. So if you're a single buyer of labor, nobody else hires the kind of labor you do, and you have complete control over their ability to work. Either you hire them or they don't work. You have a lot of market power and you can depress wage rates far below, that is the PL you see in there, the wage rate. You can depress the PL far below the marginal expenditure on labor. So you have market power. So just as we'll find out in monopoly, because of the downward sloping industry demand curve that the single firm monopolist faces, they have power over the price in the market. A monopsonist has power over the price of wages in the market. Now, monopsony is not very common. Your book won't talk about it. We can talk about it if you want. You just ask me. We can have a conversation. Some markets have been said to be monopsony, such as the baseball market, because if you're in the line to play professional baseball, they're the only people you can play for. So the baseball folks have some power over you. We don't tend to think a whole lot about that because they get such a monstrously large salaries. We don't worry about are they being exploited by the market power of the industry. But nevertheless, there are some examples that are very helpful to look at for those. So let's move to the case where there's two variable inputs. We said it was labor and capital, but what if you have, as in the first line, unskilled labor and skilled labor, or highly skilled labor and lowly skilled labor, and you have fixed capital? How do you make that decision now? Or if we let the situation go to what we call the long run, capital no longer has its bar over top of it in the second production function there, and it is variable. So in that case, um, there's an average product of each. We didn't calculate average product of capital because it wasn't variable. We didn't calculate marginal product of capital because it wasn't variable. But in a long run situation, it is. So anytime you're changing your capital, then you can be in this situation. So to get there, we actually say, well, how can we combine labor and capital? And I do apologize if you don't follow the calculus, but let me tell you what that line does. DQ is the change in output. It's the total derivative, and it's equal to the partial derivative of Q with respect to L times DL, the change in labor, and partial derivative of output with respect to capital, DK, that is the change in capital. But what are those things? You know what they are, right? The change in output with respect to labor is the marginal product of labor, and you would then immediately guess, and you would be right, that change in Q over change in K is the marginal product of capital. So DQ is set equal to 0. Why? Because we want to ask this question: what if output doesn't change? Now, how should we change our labor capital mix to be best? Should we use a lot of capital and a little bit of labor, or the opposite? So the last line gives us what economists call the marginal rate of technical substitution, and that turns out to be, we take that calculus equation, we go back to our familiar notation with the changes, and we say the change in labor over the change in capital, that was DL and DK up above, is equal to the negative of the marginal product ratio of labor and capital. And it's that ratio which is the marginal rate of technical substitution. Now, how does that help us? So let's think about what the cost situation is. The cost is the price of labor times labor plus the price of capital times capital. Remember, they're both variable now, and that implies, if we solve for K, that capital is a function of labor. It's a linear function of labor. The intercept is C over PK, and the slope is PL over PK, or we have this term minus PL over PK, the ratio of the prices. This gives us the cost trade-off. So the productivity trade-off is MRTS. The cost trade-off is the ratio of the prices. So the optimum combination of L and K, we set those together and we solve. Actually, we don't really solve, we rearrange. And when we rearrange, we get this relationship of we're looking to determine where is the marginal productivity per dollar the highest. In the last line, if the marginal, I missed that one too. If the marginal product of labor per dollar spent is greater than the marginal product of capital per dollar spent, then you optimize by, please make note, hiring more labor because it's more productivity per dollar, and you hire less capital because it's less productivity per dollar. And the equilibration is when those are equal. Again, it's a marginal benefit versus marginal cost types of thing, but the cost is the opportunity cost. I hire more labor, it's the opportunity cost of giving up capital, but I want to do that because capital, labor may be indeed more productive. So here's a problem, and here's where I want you to try to put this into action, because all of this mathematics is, I know it's hard to hold on to, and there's a lot of equations and so forth. So I'd like you to take the cost function and create a table in Excel. So you're going to have some columns, and you're going to have column L for labor, and you're just going to number that from 0 to 18. You don't, no need to go any further than that. All the action occurs before you get to 18. K, we don't know what K is. It's fixed, right? Unlike our last slide where we had the trade-off, K is again fixed, and we're going to let it equal 5. So the whole column is just 5. Why do you put the column in? Because we're going to do some simulations, and at some point in the future, I'm going to say, well, change 5 to 10, and let's see what happens. You're going to write down Q. That's the result of the equation. So you'll have a formula in line 3 or column 3 so that you'll take L and multiply by 30 plus 20 times L squared. And I'll show you how to do this. Then once we have all the headings, and start the table about row 8, that is somewhat down your page. I'll give you room for headings above it, name for cells above it, putting other information above it. And I want you then to create this table and then do a line chart in Excel to plot Q on the vertical axis, L on the horizontal. That'll be your total product curve. And then I want you to do the same thing with average product and marginal product of capital. And these should resemble what I'm going to show you here in a second. So put the table and the graphs in the same tab. We're going to call that tab 1. And I've decided to change the numbering from problem 2.1, but that's okay. You'll see the assignment that we're going to be doing. So do use Excel functions for all the calculations. Don't calculate on the side and then enter it into the Excel. That doesn't use the power of Excel, and it will prevent you from being able to simulate results. So what we want to do is to look at this and represent a business with a real mathematical cost function, which we purport to say it represents this particular business. And we want to see what happens when we change parameters, when we change characteristics and prices and so forth through all of this. So here's what you're going to produce. This is actually my Excel table and pictures. And notice that I have a number of lines up here where I just copied down some stuff. I put some notes for me, and this is right in the Excel, and you can see that here in a second. And I left the blue area to be the parameters. You know, over here on the output level, output was B, L, but B was 30, and C was 20, and D was -1, and here's capital equal 5. So my formulas to work down through the table come directly from there. And if I later want to go and say, well, what would happen if B was 15? I can do that. The graphs are tied directly to the chart. So when I change, that will change as well. Here's my Excel sheet that I actually did. And I'm going to try to walk you through a little bit of this so that you can see what's going on. If you need more assistance than this, let me know right away, and I'll either do another video or I'll try to talk to you directly. I assume most of you have had Excel somewhere along the way and you've learned to use Excel formulas. But let me show you exactly how I did this. And so this is, like I say, you can see I'm actually in Excel. I put my labels across the top here. Trying to highlight them. There we are. There's my labels, including MP Math and MP Change. So I'm going to show you how I do both of those. Those were formulas defined back in the previous video. So L, this I just typed in, 0, 1, 2, and so forth. But let's, for example, say I don't have all those typed in, and notice my graphs just did crazy things because it's live. It's doing exactly what I'm doing. So 0, 1, 2, 3, I can grab this, and because I've got a sequence going, I can just drag it down, and it went to 19. I want to get rid of that one. Okay, so now I did the same thing for capital, but I put in K is equal to 5, but look what I did. Here's the cell reference here. What I actually typed in for 5 was H8. And literally, I didn't put in that. Let me show you directly. So I've taken my capital out. Notice the graphs didn't change. I just eliminated all my capital and the graphs didn't change. Why? Because capital is irrelevant in the short run position, and you can see that by looking at what causes output. K isn't in there. But I do want this to be 5, so I put in an equal sign, right? See, I just typed an equal sign, then I went up and I clicked on that cell and see what happened. I didn't have to type H8, it's right there. And again, I apologize if you know this, but I'm trying to give you enough to walk you through all of the different calculations that we're doing here. So I press enter and a 5 shows up. Now, what I need to do though is I need to take this value, H8, and I need to fix it. And the way you fix it is to put in a $sign before the H, and that freezes the row, and a $sign in before the 8, and that freezes um, uh, the row. The first one froze the column. So now when I do an equality and I drag it down, it would have moved to H9 and H10 and so forth, but now you'll see 5 shows up everywhere, and when I click on the very last one, it's still pointing to that. And an easy way to debug formulas is just double click. I'm clicking on the last one, the formula comes up in the box, and I don't know if you can tell it because it's a blue box outline, but it's actually pointing out the cell that's being referenced. We'll do this again on this one, which is more complicated. So here in quantity, what I had to do is to run through this and calculate it as this complicated formula up here. And because it doesn't read very well, it's hard to see what I'm doing, but I'm typing exactly this. So where is B? B is this cell right here. And if I go back to my formula, you'll see E5 with $signs, because I'm freezing what's in the blue box, is right here. That's that first one. And then plus E6, well, that's value for C, times, that's the asterisk, B11. Now what I did do is I froze the B in that, but where is B11? It's the labor. So look at the formula, B, which is 30 times L, plus C, L squared. So that's what's going on in here, all right? So when I did E5, actually that was A. It used to be right there. So I don't really need that. I could actually delete that, and I think I will, just that part. So now it is the rest. Now notice when I highlight all of that, it changes colors, and the colors represent the color of the box lines, not the background. And here's L over here, and actually there are 3 boxes laying over top the L0. And I would expect you to be able to emulate that. And if you freeze it the way I did, now all you have to do is drag down. Let me do it again. I click on 0 and watch the cursor right here at the corner change into a plus. If you're not good at mousing, this will create havoc for you. You want it to be a plus, not the big plus that's usually there, but now this plus. Hold down the left button and drag it. And you didn't see any changes, but what it did was it changed everything. Here, proof. So I'll take all that out. I just have 2 of them, right? The first 2, change to a little plus sign, drag it down. There it is. Everything's back the way it was. So how do we do average product? Well, average product is just, and this one's easy because you can see the D12 is 49 divided by B12. I don't have to freeze anything because when I drag that formula, I want it to go down. I want, where at UC 66, I want that to be 132 over 2 and so forth. So again, you're seeing everything, you're seeing everything that I'm doing here so that you can figure that out. For math, I'm doing the MP for math. I'm just following this formula. B plus 2CL plus 3DL square, all right? I don't know why that's L2 instead of L square, but I think you'll be all right with that. So I did that for all through here. But MP change, here's what I wanted to emphasize. I'm looking at the marginal product for L equals 1. And what I'm doing is I'm going to quantity for L equal 2, that's D13, minus quantity for L equals 0, that's 0. Does no harm to do this, even though most times at the extreme you got to watch yourself. And then I'm dividing it by L equal 2 minus L equals 0, B13 minus B11. And when I do that and I drag that down, by the way, if you just noticed me the last two times, if I click anywhere else while I'm in editing mode, it will mess up your formula if you hit enter. So just be aware. So there, that's it. That's what you have to do. Now, how do you get the graphs? So it's a little hard when they don't all line up right away, but let me show you the first one. And well, let me do the whole thing. I'm going to highlight the whole area here, and I'm going to go up and say, let's insert a line graph. Where are the line graphs? Here we go. Insert a line graph. And then I get to choose what kind I want. Now, the things you have to watch for is don't take a stacked graph where they add to 100% or the areas are not helpful or important here. But you can see how you could float your cursor, you'll get different graphs. I just took the very first one here. And the thing that I notice about this is, see the picture has two graphs and they overlay with each other? That's good. It's also giving me a preview of what happens if I graph everything I just grabbed. And I don't want to do that. But if I do this, notice they all change because they're stacked. And I'm getting the second line on top of the first one as if they're added. I don't want that. I want this one. So here's my chart. And I can now edit this to be both of those graphs that you're required to put together. How do I do it? Well, first off, I'm going to right click and go to data. And I'm going to notice a couple things here that are kind of bad. The first is when I grabbed it, it took L as if it was a series to graph. I don't want that. So I'm actually going to click on L and remove it. If I thought, I wouldn't have used L in my whole database type of thing. But I want L over here on the horizontal axis. So I'm going to edit, and I'm going to put in the range of L. And the way I'm going to do that is select range. That just means when I click that button, I can go out here and start at 0 and go all the way down to 18 and let go. And you see what's up in here. It says from tab 1, I want to go from this value to that value. Click the button again, say OK, and there's the actual values of labor. Now, before it was the numbers 1, 2, 3, 4, 5. So you want to be sure that you get labor and not just take the default. Sometimes the default works. A lot of times it does not. Now, in this window, and I wish I could expand it a little bit more, but I can't. Notice I've got all my different values here. But what if I only want to graph Q? Well, let's take MP out. Let's take MP math out. Let's take average product out. And let's take capital out. That's just going to be a straight line at 5, so it's not going to really do anything. And now I have only Q versus over here, which is L. And there's the total product curve. You say, well, gee, it doesn't look the same. That's because it's wider. And as I edit this a little bit down, it'll get there. This button here allows me to take off the useless grid lines that I don't like. It makes it look a little bit heavy. I don't really need that. I can double click here and change the title. I'll just put TP for quickness. And I only got one line. The heading tells me what it is, so I can go here and remove the legend because I don't need it, and I now have a cleaner graph. There's all kinds of other ways to change that graph, what you want to do, and so forth. But let's say that wasn't what I want to do. I want to do the second one. So we'll just edit the data again. And the second one was not Q, but it was, I want to do AP, average product, and I want to do MP math. You could probably look by inspection that MP math and MP change are almost the same numbers. They're not going to be the same number at the margin. In fact, in this example, number 14, where it's 2 to 1, That's a big difference percentage-wise. That'll create some issues, but that's also outside the bounds of what we're going to be looking at. But I'll go ahead and put it on. It's just going to lay over top the other graph, and I'm going to say, here we go. And there's the same marginal product graph as you see above. If I move it around a little bit by the handles, I'll get it to look a different way, and so forth. And actually, you can see here the blue line sticking out, which is MP math, and the green line, which is MP change, because change doesn't have a 18th value. Why? Because to get an 18th value, I would have had to have numbers for L equal 19. So that should take you through this part and should help you actually get these done. And this is the first part of the assignment to make sure that you can get to this point. But let me take a couple minutes to go on. I know I'm at 25 minutes. I don't like to make videos this long, but well, here we go. So there's some calculations here. There's a little bit of explanation with a different example to show you about doing the MP change type calculations. But here's tab 2. Once you finish with your graph, I want you to then upload it so I can see it and have it so it works. And by working, maybe I should give you a quick example what I mean there. Let me take off this extra graphic I did, highlight the edge and press delete, goes away. But what if I wanted to say B should be 20? Watch the graphs. They'll change. Now that wasn't a big deal, but I can show you a big deal. All the diminishing returns in this model comes from D. What if I made D positive, positive 5? Then suddenly these curves do not look like the curves in our book and do not represent reality. And we can talk about why and all that, but we need a diminishing returns. How about -4? Whoa, still doesn't look very good because the relevant range of production is somewhere between 0 and 1 unit probably. But because there's so much of a value here, we're way out of bounds again. And the easy fix here is just to go back to 1. But what about 1.2? You know, yeah, that works. What did we discover? With extra diminishing returns, the total product comes crashing down earlier. The heading is a little earlier. And while this isn't the kind of simulation that we're going to do on tab 2, it is a simulation. So tab 2 is this. Add columns after you copy your table to tab 2. And the way I would copy your table to tab 2 is to use the reference cells. Go in the first cell and type equal, go over to tab 1 and click that first cell over there, and then drag that throughout your table so that your tab 2 table changes every time your tab 1 table changes. But we're going to do a lot of action on this side. And these are all the formulas that you're going to want to put in there, 2 rows of them here. And then we're going to be able to do a lot of simulation on this. And it's not a perfect example, but it does give a practical to the mathematical to the theoretical. And we can bridge all 3 of those gaps very, very easily. Now, where might the mathematical expression come from? Well, it might be your data analytic people analyzing all your past practice and saying, here's how we explain what you're doing and predict your output based upon all of the different inputs. And your firm may have 50 inputs. And here's our parameterization of that model. And if they put it together and test it, you may actually have the ability to simulate your firm under alternate expressions. So what is the goal? Well, for one, I think it's fun. I hope it's fun. But say the annual price of capital is $1,000. So you're going to have prices. And the profitability now becomes a balance between the wage you can pay your labor and the price you can get in the market. And capital's out of the way at $1,000. We may change that later. Using the economic principles of the theory of the firm and by the meaning and the breakdown and shutdown points from chapter 8, we're going to do some simulations. but start with a wage rate. This is all annual term, by the way. Start with a wage rate of 40,000 a year and a price that you can sell your product at 350 a year, and you can begin to see how a profit can be made. So, one caveat at the end, I use conditional formatting anytime that marginal product is negative. I wanted it to blank out my results so I wouldn't get misled. But if you're looking at the end result and you see a profit or you see something that looks positive or you find some conclusion, look back and see if you're producing where marginal product is negative. If you are, you're outside the bounds. You need to watch for that. And there's some other little traps in here because it's not a perfect simulation. It's not going to be programmed for every single case. The only other thing I will tell you that I did not tell you when we went through my example was that I actually backed off in this graph over here, which is let me go back to -1, our average and marginal product graph, and I'll show you how I did it, because if you scroll down on labor, see all the check marks? That's which points I want actually looked at, and darn it, I took them out. I had more points than that, 19, 20, 21, 22. I think I eventually took them out of my table because I went further than I recommend you do. And what happened was the graphs just look crazy. So you want to go back to a point where marginal product is just negative, and I've got a number of points beyond. But by eliminating those points from your graph, you can actually get to something that looks even a little bit more textbookish like. So let's take the last 3 points out. And what happens is it looks a little more textbookish and looks more like that perfect picture that you see in the chapter. Well, again, 30 minutes this time. So sorry, but I hope this is helpful. And I hope everybody who was able to do Excel from the get-go bailed out about 10 minutes ago. But there you go. And that's going to be your first assignment. See you in class.